chip thinking. So I'm going to take you through some of the aspects of chip thinking. An idea which came out of some work between myself and Bryden Wood. At the time, I was working for GlaxoSmithKline, and I formed a collaboration with Bryden Wood. Together, we call this a front-end factory. I'll talk about that a little more in the future. And out of that work and experiences from our past came chip thinking. The first thing really before we dive into anything is just have a conversation about the nature of chips. There's sort of two schools of thought. One of them is that it's sort of quite a philosophical concept around an entity which creates value. And certainly in a strategic sense, that's a good way to think about it. The other side of the equation is it's sort of quite a hard engineering object which you can measure and has a big data set associated with it. And I think the truth is that it's both things. I think different people lean to their different side of understanding, but truly it is both. It's both the idea that value is created by something, and also that something can be tied down in terms of measurements, understanding, and data. So as I talk about the chip, I need to first of all give you some of the evolution of thinking that brought us to the idea of chips. And then you can't really talk about chips and chip thinking without just discussing design to value, because chips are about value creation and they sit within an idea of philosophy of design to value. Then I'm going to try and define a chip in a bit more detail to give a bit more broader understanding of what a chip is. And then I'm going to talk about the thinking that's applied to the chip and the application of that and some of the outcomes. So if we go look at historically, probably mid 20th century, the idea of modular design had really come to the fore. You can see this probably best in the design of spaceships. So this is Apollo 11. And Apollo 11, although it's a rocket and people see it as a rocket, it's actually made up of modules with different functions and was designed in such a way with them integrated back together, partially out of necessity. But also what's interesting then is that the module that brought the people back to Earth would be then replicated in different, in some form in different rockets. So the idea that this design module rather than a whole rocket design is something that has been around maybe much longer, but certainly was seen in great detail until the mid 20th century. Another trend was in systemized design, and systemized design for me is about, if you take a building, it's about dividing up a building in a different way. The way we construct and think about the design and building of buildings is via the different trades often. So we think about the structure and we think about the cladding and we think about the piping and we think about the HVAC system and we think about the electrical system. Systemized design cuts the building in a completely different way. Really started because of looking at how you delivered buildings and looked at functional units within the building which would come together to make the whole unit. This particular one is a pier of an airport which had everything within it, all the finishes, all the M&E, mechanical and electrical systems, all the structural systems, all integrated as one design, and they could be fit together very quickly to make an airport pier, which was required after the 9/11 bombings to separate incoming and outgoing passengers really quickly. That couldn't have been delivered classically in a systemised way as anywhere near as quickly as it could by creating this systemised design. That moves on, those two things move on into design thinking, and the first time I really saw design thinking to this level was in a hospital design in the UK. And what they've done is started to look at the flow of patients through a hospital that carried out small operations, and looked at the different areas where value was created in that process, where things had to happen. So reception, getting the person in, getting them ready for the operation, having the anaesthetic, having the operation, recovering, being discharged, and each of those areas therefore had a value to it. And if you started to analyse a hospital in that way, you can work out how to design a much more effective hospital, which they did, much more efficient. It was delivered much more cost effectively and also much quicker, because you can take the modular design thinking and turn that directly into structural design and delivery based upon systemised design. So what this started to do is design thinking becomes about breaking down the problem, what you're trying to do, into its value components, and then iterating different ideas, modelling different ideas in order to get the most out of it. And that's really where chip thinking came from. So design to value is just what I've been talking about. It's about understanding what the product, idea, service, offering is required, well understood in the delivery of products and brands, not really used in the built environment much. The opportunity may be a difference between the performance now and performance in the future, or the capacity now and capacity in the future. But then it's understanding what the real value you're trying to create in making that change. And there's different categories of value. So there's clearly financial value, so the capital cost, which is a big focus, net present value, the margins. But there's also a value in what I've called the quality of the design. So that might be the brand, the impression, the aesthetics, the adaptability, the flow, things that may well have a financial impact but are quite difficult to quantify, but they're really valuable and need to be understood. And then there's obviously social values as well, around environmental impacts, things like democratization, whatever. But it's really about trying to understand what the values are, how you're going to measure them, how you're going to weight them, how you're going to balance the value of cost, affordability against margin, that sort of thing. And then what you're looking for is how value flows through it. So how value goes from the customer to maybe the supplier, maybe to the manufacturer, maybe to the, and then understand also where people hold the shared value. So efficiency of the whole system might be a shared value, and where there are differences in value. So classically, customers want affordability, and retailers often want margin. So there's a play-off there, and understand how that will be played off is important. And then what are the levers? How are you going to, if efficiency is really important value to you, how are you going to change? What's the biggest thing that's going to change that efficiency? Where's the cost? Where's the waste? Where's the lack of productivity? Whatever it is, it's about going to find what those levers are so you can start to play those through in your design process. That's design to value. And it was out of looking at that process that the chip came into fruition. And I'm just going to show you a really small clip of a video of when chips were first really talked about. So if you look at a whole supply chain from raw materials to patient, you can break that supply chain down into chunks. And those chunks we basically call chips. Now in a factory, a chunk can be a suite with a piece of equipment in it, but it could also be a piece of warehouse. It could also be a whole factory. It just depends on how you want to look at it. But it's a piece of that supply chain. So we can understand what equipment goes in that chip, we can understand the physical space that's required for that chip, and from an engineering perspective, the utilities required to support that chip. But we can also understand the people who are required to run that chip and what level of training they need to be, and what level of expertise they need to run it. We can understand how to validate it and how to maintain it. We can try and understand everything that's required to make that chip work for the overall supply chain. As you can see, chips at that point were presented quite importantly as quite a physical thing. So a bit more about chips. Chips are clearly a space definition, and that's important in the built environment because often the built environment is about creating places to do things. So it's really important, but it doesn't just define the size of the space, it defines the quality of the space, etc., which start to inform what's required from a utility perspective, etc. It's a unit of operation. Something happens there, either a piece of equipment or a person or an operation, and that operation can be defined by that chip. It then becomes a method of rapidly building virtual environments because it becomes data rich, and it can become data rich in aesthetic and modelling terms, so you can start to put these things together really quickly and have a look and see what that might be like in reality. And that's fantastic for getting feedback. Asking somebody what they want is not a very good way of getting an understanding of that. For me, the most important thing is to present something, to get them to interact with something, and through that conversation with them and that response, you get a much better understanding of what people are really looking for, and that can inform massively the design process. So capacity modelling, so each chip would have its own capacity model to understand what can go through it and its constraints, but then you put them together and you build up an overall capacity model which allows you to look at supply chain modelling, through factory modelling and through unit modelling. And then if the supply chain is not performing, you can really understand which chips you need to work on and what you might do within those chips to unlock it, etc. So it provides that whole understanding of capacity. And the real value that we've seen in this is to allow companies to phase investment. So understand how they can phase investment over time, which does in fact construction, because you need to be able to construct in a way which allows further construction and additional space to be added later without impacting the facility. But if you understand the value of doing that, even if there's some costs associated with it, it might have a fantastic return in the long term. Chip is a unit of cost operation. We do cost of goods analysis, margin analysis, MPV for all different scenarios. It allows you to play tunes and really understand how you can manage cost where cost really lies in a process. Because of the nature of the way that the data is stored, you can understand that and work through it. It's a repository of knowledge, so as well as capturing a design and maybe an equipment list or whatever, or we capture the rationale around that, so it provides a huge amount of knowledge of that process, how the process operates. Ultimately you can put the operation sequences in there, etc. So it provides a place to put all the knowledge about that value adding step within your process. And it's a unit of consumption, so if you want to understand your utility requirements now, in the future, how they might change, whatever, the chips know what utilities they need, and with the modelling, capacity modelling, etc., you can look at peak and average demand and all those things and play those things off if energy costs are important, or etc. So it helps you with energy and utility strategies. It understands what people are needed to run the chips, and therefore as you start putting the ideas of an investment together, you start to understand who what sort of people you need, how well trained do they need to be. You can start thinking about your supervision. It gives you data on things like office space requirements and canteen facilities, etc. So it's about the people as well, and understanding the human resources required to run facilities or infrastructure. And critically for many businesses, it creates an area of standardization. They can decide to standardize on chips, which reduces massively the cost of waste, of inconsistency, and so on, and allows them to repeat things within their supply chain where that's value added to them. And of course, provides all the data to do that, stops them redesigning things every time. So I'm going to talk you through a little video here which sort of pulls all that together. It shows how we've created a chip library and how we can use that to investigate a project. So this is our chip library, and if you go into each chip, there's a whole raft of data associated with that chip. And then when a project problem comes in, an idea, what we can start to do is put those chips together to understand how we might meet those capacity models. You can see some parametric design chips there. So if you understand the capacity model and the flow of product through the facility, etc., and the demand, you can look at the warehouse space and access corridor space and so on. Those are sort of calculated chips. And then utility-wise, because each chip understands what utilities requires, you can use tools to automatically look at utility runs. Not perfect, but really good for costing. This is a standardized component building system you can put on top. So you have everything you need now to do a financial analysis, capital costs, running costs for a different product range, and you can create an iteration. You can now play again with the same component parts with a different thing and create very rapidly another iteration and show the difference. So fantastic for looking at options on projects, and much more rapid process than if you do it in a traditional way. And then finally, because you have lots of digital data built up around these, and using games platforms as we do, putting the data into game platform, you can, even at these very early stages, walk into, it's a fictitious facility, but it's one based upon a section of chips that are put together. You can walk into it, have a look. This really starts to inform people, and they'll ask lots of questions, have different ideas, and those can all be reassessed back into different requirements which weren't understood, or different aspects of value which hadn't come through previously. So really valuable in early design. So chip thinking is about using chips to understand how value flows and how you're going to design a built asset to maximize the value for a business. And a chip for one person can be their supplier of product at a margin which is really good for their sales, or it can be the data required for someone who's planning utilities on a site, and everyone in between. Just some examples of where we've used chips and chip thinking. This is an example where the company was looking to build a new drinks facility in Africa. They briefed a company. The company had gone off and done a design, feasibility design, and when that came back, it was much too expensive and the business case didn't make any sense. We brought this into front-end factory. We broke the process down into chips. We started to look at what products we might leave in their existing factory and what products we might put in their new factory, how those products grew over time. What we concluded first of all is, in order to meet the demands they were looking for, which were quite high, actually the factory could be 25% smaller, cost them 25% less than they originally thought, which was really valuable. But even more valuable, the, the modelling, the financial modelling of moving those products about um, brought up the fact that bottling water in places where energy costs were very high, um, and in some parts of Africa you have to generate energy through diesel generation, actually lost you money. There was a negative margin on those products, and one of the reasons why their their original business case didn't stand up was because they were filling early um, um, underutilage of the equipment with bottled water, and that strategy just didn't make any sense at all. We uncovered, and that completely changed their strategy for delivering drinks into that marketplace. Another example of this was when we were looking at building many facilities in emerging markets potentially, and they all had different functions, all in the secondary region, so turning drug product into tablets or liquids or whatever, but all of them different. So we looked at all the different chips that were required, would be required all over the place, and then what we thought we need to do is to put a construction system, adaptable construction system around those, which could be built in any market cost effectively, rapidly, but also without use of construction people, because each area had very different levels of capability in construction. So we came up with a factory in a box, which was a componentized construction system, which could match all the chips that we could think of, both now and adaptably in the future. And factory in a box came out of that. You can see to some extent the component parts on the left hand side, and also the different facilities that could be built over time. There was, huge amounts of variation in size, and facilities could grow over time or repurpose because it was a very adaptable system, and none of it would need construction people. In fact, we tested it by prototyping with a group of ex-Gurkha soldiers to show that it didn't require construction people to build the facility, and it was signed off by our quality people. Chip thinking now keeps evolving, and one of the evolutions that came out was to look at the classification of chips. So I've talked about chips really at this sort of logical unit of transformation, or logical unit of value creation. But if you go up on chips of course organise themselves into facilities. And what we call a facility is something that is a collection of chips which sits within a particular site. So it creates a facility to do with that value chain, and it's a number of chips. And of course that's how businesses really work. Um, Going up another level though, a macro chip becomes a node in a global supply chain, in a global value chain, and you can at that level start to model, strategy, those strategic decisions, and we call those macro chips. Moving down from the chip, you've got the meso chip, and that's a logical subunit of a chip, and they once again can fall out of thinking and design. The real benefit we saw in the meso chip, though, is that's often where standardization really starts to work for you. So there's often quite a lot of pull on variation in chips, um, which really only changes the data, particularly in the early stages when you're modeling. So that's not a real problem. But in design terms, that can become quite a complex thing. Whereas if you go down to meso chips, the sort of subcomponents, you can create quite a lot of standardization and build chips up from those more rapidly. So it's really valuable piece of work. And then at the microchip level, it's sort of the component level, and sometimes we break down. But what we're trying to do is get to a level of sourcing, almost a level of that you would buy that in as a unit, because that really helps when you're putting a project together to understand how the whole process and the whole value added piece is going to come together. So that's a classification of chips. So what we started to think about is that chips and their data and the real world become become a combination of one thing, and I've called it a combination of physical and digital ecosystem. Starts off really being largely digital. However, we do prototype sometimes early on, and certainly, virtual reality sits for me between physical and digital. Certainly when you can start touching and feeling things, which is possible now. But what chips are doing really are bringing the two things together, that idea of space and physicality with the idea of digital modeling and design. And right through the project process, from the first knockings of an idea to the plant running and improving. And chips are fundamental part of organising that, because it allows you to break it down and understand how parts of it interact.
The modular concept is key to what we are doing. We start with a basic toolkit of different reactor types and different separation technologies. Then we modularize those into standard building blocks. Like Lego, we can put those blocks together to execute a recipe. 80% of these blocks would be workhorses that we would use again and again, and over time we get an ever more expansive library that we can rapidly assemble from. With this high level of standardization combined with a fit-for-purpose diversity, not only will we be able to react very quickly to demand, but we'll get precision and more reliability in our supply. The continuous batch hybrid platform is a manufacturing platform that combines traditional technologies with new ones for higher performance and data integrity. But it only works when we digitalize what we are doing. By creating a digital twin of a manufacturing facility, we can really bring to life a new way of manufacturing products. We can release our finished goods more quickly, reduce downtimes, and prove to regulators in real time that our product is compliant, ensuring higher performance throughout our supply chain.
Chips are really about holding data, about those moments in a process or value chain that add value. And the digital side is really important in terms of the learning organisation. So GlaxoSmithKline has developed chips which it has access to at different levels of design, some of them at detailed design. It has a building system, understands the components and the quality of the components and how they can come together to make rapid and cost-effective buildings. It can analyse those in its portfolio and understand where they can add most value and where to spend time in standardisation to deliver future value, and stores knowledge about its processes and its network as time goes on, which is very rich in terms of future strategizing. Modelling really important. What's really interesting to me, this is Cityscope, part of MIT. They came up with a really nice way of interactive planning and strategizing using Lego blocks on a intelligent board, which allows you to, as you move things about, to change the data. So you can recite housing, recite in a city, or recite warehouses to supply a city, and the model will tell you the impact of doing that. But together you can move Lego bricks around to simulate it. And what's interesting is we combine that with the chip thinking, and actually MI and Cityscope now tend to call the Lego bricks chips, to provide that sort of physical collaborative planning process which uses chips to help you make strategic decisions and modelling. Chips are all around us. If you go right back in history, a simple house is a chip. It provides safety, maybe status. It provides somewhere to eat, somewhere to sleep, those sort of things. Keeps the rain off. It had a value. The space inside that, the safety of that space, the family home is a chip. Um, um, an ambulance is a chip. An ambulance with the people and the things on board, and its value is to respond rapidly to people to save their lives and get them into further health. And we've talked about the pharmaceutical chips quite a bit already. But really interestingly, one of the things we're looking at is how you break airports down into chips. Here's a security area. You know, the value for the customer is to get through as quickly as possible, not have to take so many clothes off or unpack your bag too much. For the government and for the organisations, it's about security screening and making travel safe and making us feel safe, which is one of those quality of design values we talked about. And then a changing room here in a retail store. That's really important because not only are you trying to change your clothes on and you want to be able to do that in relative comfort, maybe involve someone else in the choosing of the clothes. You have some value propositions there, but the company also wants to demonstrate something. In this case, quite a plush one, wants to demonstrate its brand and so on. So that is a chip, and that has some very different values for both the company and the customers. So chips are all around us. So I hope you've enjoyed our little dalliance through chips and chip thinking. Hopefully, technology allowing, I'm going to be on the other end of a phone or Skype, and I'm open for questions. But please, feel free if you look up the Dyson project or looked up me on LinkedIn, then I'm quite happy to engage with you if you're interested in talking about it further. Thank you.